Okay, here's the solution to 6.3.4b. It can be a little bit tricky because it's easy to misread this one. For the function g of x equals 2x cubed minus 18x squared plus 30x plus 3, which is true? And then in every choice, it doesn't say the location of the min or the location of the max or the location of the inflection point. It says the value of g at the min or the max or the inflection point. So it's actually something where we're going to have to plug in our x values to the original function to find out the value of g when we match our answers to the statements. Alright, so let's start by finding our first derivative. We want to do the power rule. So g prime of x is going to be, you want to do the 3 times the 2, which is going to give me 6x squared, minus 2 times 18 is 36x, plus 30, and then plus 0. Okay, now mins and maxes come from your critical points. And critical points are what you get when you set your first derivative equal to 0 in this case. So you want to say 6x squared minus 36x plus 30 equals 0. And notice that every term has 6 as a factor. So I factored that outside of some parentheses. So I have 6 parentheses x squared minus 6x plus 5 and then close the parentheses. Okay, next, x squared minus 6x plus 5 factors into x minus 1 times x minus 5. Okay, so when you have two values that multiply together to give you 0, one of them can be 0. Now 6 is never going to equal 0, right? But x minus 1 could be equal 0, and that would give me x equals 1. And if x minus 5 equals 0, that gives me x equals 5. So those are my critical points. Those are the potential locations of extrema, maxes or mins. Now, inflection points come from your second derivative. So I need to find the second derivative. So I'm going to back up to the 6x squared minus 36x plus 30 and find the derivative of that. And that would give me 12x minus 36, and then plus 0, right? But I'm not going to write plus 0. So the location of an inflection point might be where 12x minus 36 equals 0. And if we solve that, we get x equals 3. So that is the only location of an inflection point. It's the only potential location of an inflection point. Okay, so because my statements ask me the value of g, what I'm going to do next is just plug these numbers, the 1, the 5, and the 3, into g to see which of these statements are true. Okay, so I'll pull up Excel. I tend to use Excel as my calculator. And I'm just going to say that my x values are 1 and 5 from my first derivative, and then 3 from my second derivative. And then this was g of x. And I want to do equals 2 times the x cubed minus 18 times the x squared plus 30 times x, and I'm just clicking on the A2 cell, I'm not typing A2, and then plus 3. Okay. And then I can go to the bottom right hand corner of the cell and I can either double click or drag down. All right, so remember that the 1 and the 5 were from the first derivative. So those were maxes and mins. Well, just looking at them, I see that 17 is bigger than negative 47, right? So the 17 is the max, relative max, and the negative 47 is the relative min, because it's less. Okay, the 3 came from the second derivative, so that was the location of the inflection point. So that is an inflection point. And the inflection point is actually at 3 comma negative 15. All right, and then there's the information summarized, and I just have to go through and match the answers. Okay, so the nice thing here was that Excel does the work for me, right? I just either drag it or double click, and I don't have to evaluate everyone separately. Excel does it for me. Okay, so just to kind of write that all down here, we've got the min, we've got the max, we've got the inflection point. We're just looking for the G values because that's what the statements say. So I can tell that choice D says the value of G at its inflection point is negative 15. That is what we got. And the value of G at the maximum, local and relative mean the same thing. That's 17. Okay, so this one's going to be choice D. And I'm just going to pull this down so that you can see the other choices. Like you can tell that A is wrong because it's got the wrong value for the minimum. You can tell that B is wrong because it's got the wrong value for the inflection point. You can tell that C is wrong because, again, it's got the wrong value for the minimum. E has the wrong value for the inflection point. And I think I must have cut off the rest of them. But hopefully you get the way that this is working.